So last time we mentioned what we mean by elementary row operations. Elementary row operations. Okay, so there are three possible row operations we can perform. The first one is to interchange two rows. The second one is to multiply a row by a non-zero number. The third one is to add a non-zero multiple of one row to another row. Then I'm going to tell you what we mean by the simplest form. The simplest form is called row-reduced echelon form. Row-reduced echelon form. I used to ask people what we mean by echelon, so not many people know this word, I guess. Echelon, it means in steps. Echelon, it means in steps. Okay, now let's look at the definition. Okay, look. How about I will use a particular matrix to show you the meaning. Now we're talking about what we mean by the simplest possible form. By simplest possible form, I mean there are many zeros and many ones. Probably I want to use the last matrix. Actually, not the last one. This one is not good either. I'm just going to use this one. I'll just use the last one. It's okay. For the matrix on the screen, I'm going to change the number. I will change this number to 0. So basically, I'm trying to tell you what we mean by a matrix is in row-reduced echelon form. We also call it RREF. RREF. I said RREF. It's for row-reduced echelon form. Again, the word echelon, it means in steps. Now look at condition 1. Condition 1 says if there's a row consisting of all zeros, the row must be located at the bottom of the matrix. Is that condition satisfied? Now look at the last row. The last row is the row consisting of all zeros, right? If there is a row consisting of all zeros, the row must be located at the bottom of the matrix. That's condition 1. You see the condition 1 is true in here. I was trying to say this row cannot be at any other locations. By all zero row, I mean it is a row consisting of all zeros. Easy, right? The second condition is the first non-zero entry, the first non-zero number of every row is 1. These ones are called the leading ones. Now look at the first row. Look at the first row. The first non-zero number, by the first I mean from the left to the right. Okay. The first non-zero number is here. It is required by the second condition. This number has to be 1. Okay. The first non-zero number of every row is 1. This is the leading one of row 1. These ones are called the leading ones. The leading one of row 1 is in the first column. This is the leading one of row 1. This is the leading one of row 2. It's in the third column. This is the leading one of row 3. Required by the third condition, the first non-zero number of every row must be 1. These ones are called the leading ones. Easy, right? Now condition 3. In condition 3 is the meaning of echelon. That's what we mean by echelon, in steps. You can read the sentence. It means the leading one of the second row is to the right of the leading one of the first row. The leading one of the third row is to the right of the leading one of the second row. It's kind of the leading ones are something like this in steps. This is what we mean by echelon in steps, right? Again, it means the leading one of row 2 is to the right of the leading one of row 1. Leading one of row 3 is to the right of leading one of row 2. The last condition is the most important condition, probably. The last condition, it means all other numbers in any column with a leading one are zeros. You have to check the condition for all columns with a leading one. Can I just call the column leading one columns? Column 1 is a leading one column because it has a leading one of row 1. I'm talking about column 1. That way is column, that way is rows. I know some people were confused about columns and rows in past years, so not you guys. You guys are smart. Column 1 has a leading one of row 1, has the leading one of row 1. It is required by the last condition that all other numbers in that column are zeros. You see that condition is satisfied, right? For the last condition, you do not have to check column 2. Why? So because there are no leading ones in column 2. Leading one of row 2 is in column 3. For the last condition, you check column 3. In column 3, leading one of row 2 is in column 3. So you have to check that column. You see, except that leading 1, all other numbers are zeros. So condition 4 is satisfied for column 3. Right? You do not need to check column 4. You see a 1 in here, but that 1 is not a leading one. Does that make sense? Leading one has to be the first number in some row. This is not leading one. So you do not need to check you do not need to check the last condition for column 4. But you do need to check the condition for column 5. That's leading one of row 3. In column 5, I believe that's column 5. In column 5, you have leading one of row 3. Now remember, I changed that number to 0, right? So because I want the matrix to be reduced echelon, in row reduced echelon form, if we change this number to 0, then the last condition is satisfied for the last column, for column 5. These are the 4 conditions. If a matrix satisfies all the 4 conditions, then we call the matrix as in row reduced echelon form. That's what we mean by the simplest form. Now let's go back to the question we just did. Okay, now let's try to check all the conditions for that matrix. That matrix is indeed in row reduced echelon form. Probably I forgot to mention, if there's a row consisting of all zeros, the row must be located at the bottom of the matrix. I'm talking about condition 1. If there are no rows consisting of all zeros, then you do not need to check that condition. So this is the case. In this matrix, there are no rows consisting of all zeros, right? So you do not need to check condition 1. Now let's recall the meaning of condition 2. Condition 2 is just the condition talking about the leading ones. And by the way, you do not need to copy this screen. This screen is on the course menu. You do not need to copy that. The second condition is says the first non-zero entry of every non-zero row is 1. That's the leading one of row 1. That's the leading one of row 2. Right. Condition 3 says it means the leading ones are in echelon, are in steps. You see, leading ones are in steps, right? So leading one of row 2 is to the right of the leading one of row 1. I'm pretty sure you can remember the meaning of the last condition. The last condition says when you have a column having with a leading one, all other numbers are zeros. The first column is a leading one column because the column has a leading one of row 1. It is required all other numbers are zeros, right? Likewise, the second column is a column with leading one of row 2. This number is 0. You see all the 4 conditions are satisfied. So that's why the matrix is in row reduced echelon form. It's in RREF. Just say RREF. Okay. After getting the matrix in row reduced echelon form, that's what we meant by the simplest form. And then we can get the solution to the system. You see, every column corresponds to an unknown. The solution is x equals 1, y equals 1. That's how we get the solution, right? That's the idea. Any questions? Any questions about what we mean by row reduced echelon form, REF? Actually, we are going to do a few questions to illustrate the meaning. Now get your handout. In handout, you have question 3. You have question 3. How about I'm going to copy all the questions on some slide. Now I want you to take a picture of the screen. Take a picture of the screen. When I do the next question, I may not go back to this screen to talk about the 4 conditions. Take a picture of the screen, please. Or you can do a screenshot. You know how to use your computer to do a screenshot. Now look at the question. The first thing we do is so how about we do the first thing first? To determine if a given matrix is in row reduced echelon form. Now look at the matrix in question 1. Is the matrix in RREF? Is the matrix in row reduced echelon form? A row consisting of all zeros is located at the bottom of the matrix. Condition 1. Condition 2 is about the leading ones. That's leading one of row 1. That's leading one of row 2. The first non-zero number of the rows, right? Now condition 3. The leading ones are in steps. Condition 4. Check the leading 1 columns. That's a column with the leading 1. Other numbers are zeros. That's a column containing leading 1 of row 2. Other numbers are zeros. So the answer to question 1 is yes. This one is indeed in row reduced echelon form. So that's yes. Okay. Now look at question 2. Is the matrix in RREF? Is the matrix in RREF in question 2?
No, sir.
No, it's not. So because the first row is a row consisting of all zeros, it's not located at the bottom of the matrix, right?
Yeah.
So now look at the second part of the question. Look at the second part of the question. Is it possible to perform some operations? Turn off your microphone, please. Turn off your microphone, please, if you are not talking. Thank you. The second part of the question is it possible to perform some elementary row operations to make the matrix RREF? We can interchange rows. For question 2, we can interchange rows, right? But you cannot perform only one operation. If you interchange row 1 and row 4, it will not work. you have to interchange row 1 and row 2, and then interchange row 2 and row 3, interchange row 3 and row 4, then it will work. So the answer to question 2 is no. For question 2, I just give you the notations of the operations you have to perform to make it REF. You interchange row 1 and row 2, and then you interchange row 2 and row 3, and so on, right? I believe the next one is you interchange row 3 and row 4. After performing 3 operations, I believe you can put the matrix into REF.
When we're showing our work for that, are we allowed to write your notation like you have and then just go from the very first matrix to what the last matrix would look like?
I know what you mean. I know what you mean. For this question, it's simple, but for other questions, no. For this question, it's okay. This question is only designed to illustrate the meaning of row-reduced echelon form. So I do not want to make the thing too complicated. Okay, now question 3. For question 3, you just look at the 4 conditions and tell me the answer is yes or no. For question 3, is the matrix in REF? Is the matrix in REF? No.
No.
So what's the problem? So you tell me a number with a problem. 3 has a problem, right? That's leading 3, that's not leading 1. That's why I think the third condition is not satisfied. Now the second part of the question, what operation you want to perform to make the matrix REF? I'm talking about question 3. How to perform an operation to make the matrix REF? Well, how to perform an operation to make the matrix REF? This location is the only location with a problem. How can we make this location 1? Yeah, you do not add anything. You multiply row 2 by 1/2. You multiply row 2 by 1/2. For question 3, the operation we are going to perform, I believe there's only one possible operation you can perform. You just multiply row 2 by 1/2. The notation is something like this. The operation is the new row 2. You perform that operation, you can make the matrix REF in row reduced echelon
Excuse me,
form.
sir.
Right.
I think it should be 1/3 to make it 1.
1/3. You're right. Sorry about that. 1/3 is right. 1/3. Okay, so that's the answer to 3. Okay. So basically, the operation you want to perform is to multiply row 2 by 1/3. So that's the wording. Now look at 4. Actually, when I talk about the definition, I should have given you 4. Is the matrix in question 4 a matrix in REF?
Yes.
I think yes. Condition 1, O0 is at the bottom of the matrix. I'm still reviewing all the 4 conditions. Condition 2 is that the leading ones, right? The first non-zero number of all the rows are 1s. So leading one of row 1, leading one of row 2, leading one of row 3. You do not check that condition for the last row. Of course, the last row has no O0s. Yeah, there are no 1s. You see, the first 3 conditions are satisfied. The leading ones are in echelon form, in steps. The last condition, can you check the last condition? Leading one of row 1 is here. All other numbers are zeros. Leading one of row 2 is here. All other numbers are zeros. Leading one of row 3 is here. All other numbers are zeros. Right? So because all the 4 conditions are satisfied, the answer to question 4 is yes. Again, the question is designed to show you the meaning of row-reduced echelon form and together with how to choose the operations. Now look at 5. I'm telling you the answer is no. The matrix in question 5 is not in RREF. Can anybody tell me which condition is not satisfied? Just
The fourth condition.
the fourth condition. The problem is that.
-2.
Yeah, -2. Now, one additional question. How can we perform an operation to make that location 0? You want that location to be 0. Now my question, I'm going to restate my question. The question is, what operations we can perform to make the matrix REF? That's question 5. Yeah, that's right. Probably 2 or 3. That's what you meant, right? You see, we can use that one to make this location 0. The operation we are going to perform is to think 1 times what number and then plus this number is equal to 0. We add the multiple 2 multiples of row 3. Yeah, so you're right. 2 multiples of row 3. We add 2 multiples of row 3 to row 1. And then row 1 is changed. If we perform that operation, then we're going to make this location 0, right? And the resulting matrix is in REF. Any questions? How do we get this 2? You think this 1 times what number, and the circled 1 times what number, and then plus this -2 is equal to 0. We wanted to make this location 0, right? This question mark will give you the multiple. You see, we're looking for 1 times what number and then plus 2 is equal to 0. You know 1 times 2 and then plus -2 is equal to 0. That 2 will give you the multiple. And then you have to change other numbers correspondingly. Okay.
When you say you put the multiple in and we're doing multiple of 2, wouldn't it change the entire row?
So because
wouldn't it be like your top row in number 5? Wouldn't it be 2?
Now listen to me. So the only number that will be changed is that number. So because of all the zeros here, any multiple of 0 is equal to 0. This number is going to be changed. The only number that will be changed is that number. All other numbers in the first row are not going to be changed. So did that answer your question? A very good question, I think. So don't worry. So very shortly we are going to talk about how to choose the operations. Okay. Actually, we are talking about how to choose the operations right now. It's on this screen actually. The stuff on this screen is not in the course manual. Take a picture, please. So because I'm trying to change this part of the thing, that's a simple version of how to perform Gauss-Jordan elimination. It's the procedure of putting a matrix into REF for any matrix. Now take a picture. I do not have time to give you a copy today because I have only 1 hour. Now take a picture, and then we are going to follow the step procedures and talking about how to solve a larger system, how to make a matrix REF. Take a picture, please. This one is the simplified version. In the notes, you have a longer version. This version is a simplified version of putting a matrix into REF. The whole procedure is called Gauss-Jordan elimination, or some people call it row reduction. Gauss-Jordan elimination. Turn off your microphone, please. Okay. I think we have time to do at least one question today. Okay. We're going to talk about how to use the matrix method, use Gauss-Jordan elimination, using the row reduction method to solve a pretty large system, a system with 3 equations and 3 unknowns. Next week we are going to be able, probably on Monday, we are going to be able to solve a larger system. By larger, I mean no matter how many equations, no matter how many unknowns, we can solve a larger system. But today we concentrate on a system with 3 equations and 3 unknowns of that. From this, you are going to see a big picture of how to solving a large system. The question is to ask you to solve the system, not the solution. I think I can start from here. For any linear system, no matter how many equations, no matter how many unknowns, if I want you to use row reduction, if I want you to use the matrix method to solve the system, the first thing you do is to write the augmented matrix. Augmented matrix. It's too easy. I think for all of you guys, it's easy. Anybody want to tell me the first row very quickly? 0, 1, 1, 3 is the first row. The second row, I think, is 1, 1, 3, 8. The third row is 2, 1, 6, 15. This matrix, now let's recall the term. This matrix is called the augmented matrix of the given system of linear equations. I want to put up a bar to separate the coefficients and the constant term. The last column is determined by the constant terms, right? That's the augmented matrix. That's the augmented matrix. Okay. And then look at the step procedures. In here. The next thing we do is to create leading one, to make leading one of row 1. Basically, we want to make this location 1. This location is 0. There are many ways we can do, but the simplest way, anybody want to tell me how to make this location 1?
Interchange by row 2.
Yeah, interchange row 1 and row 2. The operations we are performing are elementary row operations. When I talk about changing, you have to use elementary row operations to change the matrix. We use a notation like that. Simran told me to interchange row 1 and row 2. The first step is to make this location 1. To create, I think the wording is to make leading one of row 1. The first row now becomes 1, 1, 3, 8. The second row is 0, 1, 1, 3. The third row is not changed. I think 2, 1, 6, 15. I mentioned the last time, For a matrix, you need to use square brackets in here or here and here, or round brackets. You have to include brackets. Now I'm going to circle this number. This number is not going to be changed in the whole procedure. We want to perform a list of operations to make the matrix REF in row reduced echelon form. Now look at the second step. This one is to use leading one of row 1 to create zeros at all numbers right below that leading one. So that's the meaning. Okay. What we meant is to use this leading one to make this location 0, to make this location 0. This location is already 0. You do not have to do anything about that. Now the problem is what operation you can perform to make this location 0.
Maybe multiply by 0 to root 3.
No, we cannot multiply a row by a 0. We have to multiply a row by a non-zero number. In most cases, this can be done by performing elementary row operation number 3. Anybody want to write the notation for the operation we are going to perform to make this location 0?
I think maybe by adding -2 in it.
Yeah. So -2 is correct. -2 is correct. I will tell you how to get the multiple. To get the multiple, you think 1 times what number then plus this 2 is equal to 0. I'm going to write it down. Okay. You think that's your brain. You think 1 plus what number then times 2 is equal to 0. I did something wrong. You think 1 times what number and then plus that 2 is equal to 0. That will give you the multiple. So the question mark is -2, right? That will give you the multiple. So the operation we are going to perform is to add -2 multiple of, I'm going to write a longer line. The operation we are going to perform is to add -2 multiple of row 1 to row 2. And then, sorry. So can I try again? I think I got the wrong order. To multiply row 1 by -2, I told you how to get the multiple, right? If we multiply row 1 by -2 and add the multiple to row 3, we want to make this location 0, and then row 3 is changed. Again, the meaning of the notation is the new row 3 becomes the old row 3 times then plus -2 multiples of row 1. Okay. You're going to see how this will work. We wanted this location to be 0. Okay. So row 1 is not changed. So it's 1138. And then row 2 is not changed. 0113. Row 3 is 0. Okay. You have to change other numbers correspondingly. -2 times 1. Now remember the multiple is -2. -2 times 1 is -2 plus this 2 is 0. That's how you get this 0. Okay. -2 times this 1 is -2, and then -2 plus this 1. I think you have -1 in here. And then the multiple is -2. -2 times 3 is -6. Then plus 6, you have 0 here. Is that right? And then -2 times 8. negative 16. Negative 16 plus this number 15. I think you have negative 1. Okay. So because that's the first time we are doing this, I'm going to do this row for you. So we are done the first round of step 2. We are done step 2 actually. In step 3, we just repeating. We just repeat what we did in step 2. We repeat for all the rows. Okay. We repeat for all the rows. So basically, in next step, that's going to be the leading one of row 1. The next step is to make leading one of row 1. This location is already 1. We do not have to do that, right? And then what we do is to use this one to make the number below, or the numbers below zeros. We want to use this one to make this location 0. Anybody want to tell me what to do? So just tell me the multiple. What's the multiple? We add what multiple of row 2 to row 3? Then we can have the new, then we can make this location 0.
Simple addition.
Yeah, multiple of 1. Multiple of 1. Okay. We just multiply row 2 by 1 and add the multiple to row 3, and then row 3 is changed. Again, I wanted to use the circled number, the leading one of row 2, to make the number below 0. Okay. So basically, you think we multiply row 2 by what number, and then add the multiple to row 3 can make that location 0. The multiple is 1. The multiple is 1. So because 1 plus negative 1 is 0 already. Now I will give you a little time to get me the new row 3. Get me the new row 3, please. And then we compare the answer. I want you to do it on your own, so you can compare the answer. I do not want you to copy, so please, I want you to try something, and then after you are done, you can write your new row 3 on the screen. Write your new row 3 on the screen, please. Write your new row 3 on the screen, please. 0012. I think that's right. 0012 is right. At this point, we are done the first round. But still, if you see this number is not 1, you have to make that location 1 first. So before you move on, okay. The resulting matrix is still not in RREF yet. It's not RREF. And then we go backward. And by the way, in past years, I used to use a different way. Now I realize there's a simpler way to avoid many mistakes. And then we go backward. If you look at the step procedures, we are done step 3. So basically, we made all the numbers below the leading ones zeros. We made all the numbers right below the leading ones zeros. Below the leading ones. And then we're going to do step 4. For step 4, we start from the last row. Okay. Start from the last row, and then is it message has a lag? We start from the last row. And then we use the leading one of. You have it on the screen, okay? You have it on the. You have the step procedures on your phone probably. I will tell you the meaning of the next step. I don't even remember the step number. The meaning is we go backward. Start from the leading one of the last row, and then we use this one to make these two locations zeros, and then we go backward. So because that matrix is still not in REF yet, we want to make the whole thing REF. Okay, now we are going to use this one to make this location 1, to make this location 1. When we do this, it's permissible to perform two operations in one step. Perform two operations in one step. By that I mean, okay, I will tell you what I mean very shortly. But now think, how can we make the circled leading one of row 3 to make this location 0? We want this location to be 0, required by condition 3. So just tell me the multiple. We add the multiple of row 3. We add what multiple of row 3 to row 2? We can make this location 0. Yeah, -1. So -1 is right. You think that leading 1 times what multiple and then plus this 1 is equal to 0? That will give you the multiple, right? 1 times -1 and then plus 1 is equal to 0. So the first operation, one operation we perform is to multiply row 3 by -1 and add the multiple to row 2. And then row 2 is changed. We change row 2. Okay. Our target is to make this location 0. Do not write row 1 yet. Okay. Write from the last row. The last row is 0, 0, 1, 2. Now we work on row 2. Row 2 is 0, 1. These two numbers are not changed. So because of these two zeros. And then this number is going to be 0. So because 1 times -1 and then plus this one is equal to 0. And then this number times 2 times -1 is -2 plus 3 is equal to -1. It's equal to 1. Sorry, right? 2 times -1 is -2 plus 3 is equal to 1. So this location is going to be 1. I told you it's permissible to perform two operations in one step. Only in this case. Only when we make zeros. When making zeros, it's permissible to perform more than one operation in one step. By that I mean the next operation we are going to perform is to use this one, the leading one of row 3, to make this location 0. So tell me a multiple. So just tell me a multiple. You think 1 times what number and then plus this 3 is equal to 0.
-3.
Yeah, -3 is right. Okay, so the operation we are going to perform is we multiply row 3 by -3 and then we add the multiple to row 1 and then row 1 is changed. Okay, the meaning is we change row 1. The new row 1 becomes the old row 1 plus or minus 3 times row 3. We're going to get the new row 1. This number has to be 0. You have to get all other numbers correspondingly. We wanted this number to be 0. Actually, so these two numbers are not changed, right? These two numbers are not changed. We wanted to make this location 0. Okay. Anybody want to tell me this number? Yeah, this number is 2, right? I think this number is 2.
+2.
Yeah, this number is 2. So 2 times Negative 3 is negative 6, and then plus dot 8 is 2. We're almost done. So basically, we're almost done. So in one more step, we're going to be done. Again, the second round is to go backward, starting from the leading one of the last row, and then you make zeros. Now we go back to the second row. Okay, this is the leading one of row 2. In next step, we're going to use this leading one to make that location 0. Eventually, we're going to have the matrix in REF. Okay, I will give you 1 minute to try to get me the new matrix. I told you the last thing we do is to make this to use that one to make this location 0. Now I'm looking for the operation you're going to perform. I'm looking for the last matrix. You're going to see the last matrix is going to be in REF. Now I'm thinking about I remember the question Ben asked. For this one, you have to write all the operations and all the middle matrices to show me the work. Okay. Do not give me only the list of the operations. You have to show me work as shown on the screen. Now I want you to work out the last matrix. The last matrix, I still want to write backward. 0, 0, 1, 2. Zero one zero one. The last matrix, I think 1 0. This number is probably 0. Sorry, I don't know your question, Karen. In last question, we can only write operation. No, you have to write all the matrices. You have to write all the matrices. I mean, only operations are not efficient, are not surface. I mean, can anybody tell me the last number in the REF? So just tell me the last number in the REF, please.
1.
1. I think 1 is right. Yeah, this number is 1. We were using the second row. I was thinking about something different. Still, I want you to honestly check, is the last matrix in REF? Is the last matrix in REF? I wanted you to check all the 4 conditions before you can get the solution. I'm sorry, I forgot to write the notation for the operation. From here to here, we multiply row 2 by -1, and we add the multiple to row 1, and the row 1 is changed. Yeah, that's good. That's good. That's good, Simran. Okay, is the last matrix in REF? Check all 4 conditions. It's very important to make sure the final form is in REF, is in row reduced echelon form, before we get the solution to the system. Okay? You check all the 4 conditions. I believe the last matrix is in REF. All the 4 conditions are satisfied. Okay? Good. We say it is in REF. It is in row reduced echelon form. Something is in some form. So that makes sense? Okay. Now the whole picture. You have a system. You're given a system of 3 linear equations in 3 unknowns in this case. No matter in the future, no matter how many equations, no matter how many unknowns, no matter how large the system is, we start from the augmented matrix, and then we perform a list of operations. I told you how to choose the operations. Right? Make leading one of row 1, and then use leading one of row 1 to make these two locations 0, and so on. And then leading one of row 2 is here. Use that leading one to make the number below 0, right? And then you go backward. Eventually, the matrix is going to be REF. After getting a matrix in REF, after getting the matrix in REF, I said the matrix. So because it can be proved REF, the final form is unique. By unique, I mean the different people can perform different operations, but the final form is the same. The final form in REF is all the same. That's what we meant by unique. Okay. By that I mean different people can perform different operations when creating leading one and so on. But the final form, our final form, is always the same, as long as you did everything correctly. Now the solution. After getting the final form, we are ready to have the solution to the system. Anybody want to tell me the solution to the system? Anybody want to tell me the solution to the system?
x1 equal to 1.
Yeah.
1.
x1
equal to
equals 1.
3 equal to 2.
Again, each row determines an equation. The first row determines the equation x1 equals 1. And then the second row gives you the value of x2. x2 equals 1. And then x3 equals 2. That is the solution to the system. Actually, this is the case. The system has a unique solution, has one and only one solution.